Hey, hello there, welcome to CS School channel. In this video we are going to understand caching. So if you have talked with any software engineer in your organization and if you ask him or her like how to increase the performance of my application, like my application is running really slow and I want to improve my performance, and you have asked for his suggestions. So the first reply that he or she will give you is to use caching. Okay, so we will understand what is this caching and how we can use the caching in our system. So here is the definition of the caching. Caching is nothing but storing reusable responses in order to make subsequent requests faster. Okay, so whatever responses which are coming from the server, we can store them somewhere so that we don't have to go again and again to that particular DB or to that particular service and fetch that responses again. Okay, so that's the gist of caching. Now let's try to understand caching with an example. So let's say you have joined an organization which want to build a blogging platform. Something like Medium. So if you are not familiar with Medium, I will highly encourage you to go to that site. It contains like a list of blogs which are written by software engineers and a lot of great people. They write blogs and you can read them. Okay, so this is what Medium is. It's a famous blogging website basically. Okay, so let's say as your first task you need to build a Medium. Now in Medium there are like blogs and you need to display their blogs onto a web page. Okay, so here is your client is your basically browser, your mobile phone and everything else with which you can access the internet. Okay, here is your server and here is your DB. Suppose you have chosen something like MySQL to store all your blogs. Not a great choice by the way, but let's say you have done that. Okay, so in a typical architecture your client will make an call to your server. Okay, server will decide which blocks will be sent to you. It will fetch that blocks from the DB and at the end it will send it to the client. Okay, so basically client is making the request, server is doing some calculations to fetch the blocks. After that it will make a request to the DB saying that I need this blocks. DB will return those blocks and server will send those blocks to the client. Okay, so this is the normal architecture, client server architecture. Okay, now let's assume there are 100 different users for this platform. Okay, and every user is kind of using this site only once in a day. Okay, so in a day you are kind of making 100 requests to the server as well as to the DB, because for every request server is going to the DB as well, right? So this is something that you need to keep in mind. Now normal latencies of DB are in some millisecond, like 10 or 20 milliseconds. Okay, it may not sound a lot, but trust me, when this entire loop is completed your API latency becomes in seconds. Okay, so consider as this is MySQL DB will have generally a latency of 10-20 milliseconds, so it will return a response in 10 or 20 milliseconds. Okay, so your entire response will take around 200 to 300 milliseconds or up to a second to return to the client. Okay, so client needs to wait up to I guess around a second to get a response from the server. Okay, so this is normal client server architecture in case the caching is absent. Okay, so now we have made a small change in our application. Okay, we have introduced this caching layer in our application. Okay, so there are many popular in-memory databases which are used as cache in like all production systems. So Redis is one of them. Okay, so we have used Redis to provide caching in our application. Okay, now our application's flow will change a little bit. Okay, so client will make a request to the server. Okay, so server will do its computation, but instead of searching in a DB for all the blocks, it will go first to the Redis. Okay, and it will check if the block exists in this cache or not. Okay, so if the block exists in this cache, it will get that block and send it to the client. Okay, if the block doesn't exist in the cache, it will go to the DB. It needs to go to the DB. Okay, it will fetch that block from here. Okay, and it will then send it to the client, and in the background it will do some computation and decide whether to store some of the blocks in cache or not. Okay, so there are many popular algorithms, the simplest being FIFO, first in first out, means the old blocks will be removed from the cache and the new blocks will be stored in the cache. Okay, so as cache has limited memory, we can store certain amount of data in it. Okay, that's why we need to decide which blocks we need to store in the cache and which not to store. So frequently accessed blocks need to be stored in the cache. Okay, so there are many algorithms. We will not go into detail in each of them, but do remember there are algorithms which decide whether a particular content needs to be stored in the cache or not. Okay, so also one another thing about this caching storage is that it's a in-memory storage. Okay, so all the data that we put in this DB doesn't go into the hard disk. Okay, so that's why the access speed of these DBs are fast. So suppose DBs are taking like 10 to 20 milliseconds, this will take 10 to 20 microsecond to get the data to the server. Okay, so that's how fast cache data is, and that's why we prefer caching over accessing the normal DB. One another thing, the number of requests that will go to the DB now. Okay, so in a day, let's say 100 customers are accessing our app. Previously 100 requests used to go to the DB, but now first request will go to the DB because the caching, let's say the caching data is not present. All other 99 requests will go to this cache. Okay, so only one request is going to the DB now. So the load on our DB is significantly reduced. So that's the second advantage of caching. Okay, the first advantage being the speed of the access. The second advantage being the number of requests on DB have reduced significantly. Okay, so hope you are clear with this architectural change. Okay, now there are certain terminologies that you need to understand to use caching. Okay, so the first terminology is cache hit or cache miss. Okay, so suppose you are making a request to the server and server is trying to find that particular piece of content in your cache. If the server finds the content in a cache, it's called cache hit. Okay, and if the server doesn't find that content in a cache, it's called cache miss. Okay, simple. Then we have another terminology called as hit or miss ratio. Okay, so there is a ratio that is allocated to cache, specifying that how much hits are occurring on that cache. Okay, so in 100 requests, let's say like 10 are going to the cache, and we are finding that content in a cache, it's called 10% hit ratio of a particular cache. That cache will have 90% miss ratio because 90 requests out of 100 are missing the content in the cache. Okay, and the third terminology is cache invalidation. Okay, so let's say we have updated a blog in our DB. Okay, as that blog is loaded into the cache, the old data is served to the users, right? So there must be a way to remove that blog from the cache, and that's what we call as cache invalidation. Okay, generally we write logic on the server side to remove any particular piece of content that is getting updated from the cache, and the process is called cache invalidation. Okay, so hope you are clear with these terminologies. So in the industry, there are certain databases which are preferredly used for caching, and these two, Redis and Memcache, are kind of two of the most popular databases. Okay, so if you look at Redis, it's a in-memory data store. Okay, so your values are stored in memory, not on the hard disk, in memory. So if there is an outage, like the electricity goes away or the server crashes, then your entire data will be lost. So it's not recommended for persistent data store, but caching, yes, you can use it. Okay, so it stores data actually in a form of key value. Setting the data, you will say set key, this will be the key, and the value of the key will be this one. Okay, and it will remain in the memory. Okay, you can actually give some amount of TTL, time to live. After that, this value will be removed from the memory. So we can use this as a caching technique. Let's say you can set a key with a TTL as 24 hours. So after 24 hours, that key will be gone from the memory and you will get some freed up memory. Okay, so this is the Redis. Another popularly used DB is this Memcache. Okay, so this is again a key value store which is storing data in memory. Okay, so basically these are the two most popular in-memory databases which are used for caching. Okay, so hope you are clear with this. So these are all the things which I wanted to discuss about caching in this video. Okay, I have written a blog on this as well. You can go and check out that blog on medium.com. Okay, so do check it out if you want to read the text version of this particular video. Hope you find this video helpful. Do subscribe to our channel. That helps us to stay motivated and continue making more such videos. Thanks for watching.